Hi everyone and welcome to my YouTube channel. So we're continuing our IMO playlist, IMO Press Problems playlist, and today we're going to start with the fourth IMO, which is IMO 1962. So this IMO was held in Czechoslovakia, and as we're doing always, we're just going to solve problem 1 and problem 4 of this IMO. So basically in this video we'll be solving problem 1, and in the next video we'll be solving problem 4 of the fourth IMO. So actually this in this problem 1 is basically about of course it's number theory, because it's about moving some digits of some number. So what are we waiting for? Let's get started. So the problem statement goes as the following. So we were asked to find the smallest natural number n, such that we have two properties for n. One, the first property is that its decimal representation has 6 as the last digit. So basically that means that the unit digit here for number n is basically 6. Alright. The second property is that if the last digit, which is 6, is moved to the front of the remaining digits, so basically we're taking it from the rightmost to the leftmost of the digits, so then the resulting number, because we'll get a new number of course, the resulting number is 4 times as large as the original n. So now basically here we have an equation, if we take the 6 from the unit digits to the first digit, we'll get a number. This number is 4 times, the original n, so 4 times n. And basically we need to find the smallest such number. So here is a nice thing, that we don't need to find all such numbers, we just need to find the smallest one. Alright, so basically what we're going to do here is simple, because we clearly we just need to express this thing here using just of course using variables and stuff like that, equations. So basically let's say that our number n is of the following form. So we need to find clearly represent decimal representation. So let's say that our number n, we'll write it in its decimal representation. So guess what? We know that its last digit is 6. So basically we can write 6 here, the unit digits. And here actually let's say that this, we basically don't need to express all the digits here. Let's say basically here we have, for example, let's say a. Something like that. So a is not a digit, be careful, it's not a digit. However, a is a set of digits here. Basically it's all the digits except for 6. So let's say something like this. Or as we mentioned, a is not a digit, so this is not really formal. However, a is just the other numbers. So let's say a1, a2 up to something like an, for example. Alright, or ak. So n is basically this thing. So when we will do this process here, it will become the following. So let's say it's n prime. We will get this. And basically what we know here is that n prime is equal to 4 times n. And now basically we have everything in our hand. This is basically what all the statement is about, and we need to find the smallest such n. Alright, so clearly we shouldn't just handle them using this way. We need to express the digits to get some equations, because it's useless just to say that this is 4 times this. So we need to expand this, to represent it using powers of 10 to get actual equations. Alright, so basically we will just first of all express n using a and 6, and the same for n prime. But to do that, actually, we need to assume another, to find another variable, which is the length of n, the length of n. So what is the the number of digits of n? So let's say basically it's k. We just assume that it's k. And now we will get something really nice about it. Now we can express everything easily. Alright, so how can we express n? So basically, n is equal to, how do we represent any number actually? For example, if we have this number, 1, 2, 3, 4, this number is the last, like we take the unit digits alone, and then we take this, like this digit 3, and we multiply it by 10, right? And for 2 you multiply it by 100, 10 squared, and for 1 you multiply it by 1000, and so on. So basically like the same thing holds here. So how can we represent n? So simply n is 6 plus, well, this thing is just 10a, and as we mentioned, a is not a digit, a like is a number actually. So n equals 6 plus 10a. Alright, that's n. What about n prime? So like here it gets a bit tricky. Well, a, first of all, we take a as it is. However, the main problem is for this 6. Like it is 6 times 10 to some power. Well, what is this power? Well, like we know that, like basically, let's see what are we doing here. Like the first digit 4, or sorry, the last digit 4, we multiply it by 10 to 0. So like the first one, digit 1, 10 to 0. Digit 2, 10 like to the second power basically, or sorry, to the first power. 3, 10 to 2. 4, 10 to 3. So basically what we are doing, like if we have this is basically the ith digit, then we multiply by 10 to the I minus 1. So it's just like that. Alright, so now what is like the index of 6 basically? Because we know like this has like a length k, so it's basically k. So it's k. So what do we multiply by? 10 to the k minus 1. So like we should be really careful about this. So it's k minus 1. Alright, so now basically we know what is n prime, we know what is n. Now we just like rewrite the equation here and simply try to solve it. Alright, so let's erase this here. And now we'll just write the equation here. Alright, so n prime, which is this thing, a plus 6 times 10 to the k minus 1 is equal to 4 times n, that is 24, plus 40a. Well, clearly we can take a there, and it will be 39a. And clearly, like we can divide actually by 3, right? Because 39 divided by 3, like is basically 13. This divided by 3 is just 8, and this one is 2. So basically, like actually we'll get the following. 2 times 10 to the k minus 1 is equal to 8 plus 13a. So that's our nice little equation. Alright, so basically we know that n is this thing, n is 6 plus 10a, and we just like need to find basically like all of these conditions is basically just this equation. So we need to find the smallest natural number n that satisfies this. And it makes sense, like how can we decrease like the number n? Clearly we don't want it to have lots of digits, right? So basically we should try to decrease k. We should like pay attention to decrease k, to find like the smallest like k, because like it only makes sense to do so. Alright, so how can we like actually handle this equation? So clearly like this equation is with natural numbers we're dealing, because a is natural number and k as well. So how can we like solve such a thing here? Clearly like we don't want to solve it, however we just want to find the smallest natural number n. So basically like when you have equations, and clearly like actually if you've solved like some number theory problems before, then you should be aware that like a common technique here is to try some like modulo some numbers, because here we have a power, like, and usually that's basically related to Fermat's theorem, or to basically the order of a number. We can use it here, like if we discuss some modulo some number. But like how can we know what exactly which number we should use here? Actually, like there's like actually usually it's like random. Like you try 2, you try 3, you try for example 5, 7, and so on. However, the first thing that you should try to do is like to try the coefficient, like here the constant numbers here, because like if you take for example modulo 8, let's say, like this will become 0, right? And that's really like helpful here. So let's decide like what should we do here. So first of all, if we clearly took modulo 2 here, this is modulo 2, this is 0, this is 0, then that means that a is even. So that's really like a useful like piece of information, like we know that a is even. Good. What other thing like can we like conclude from taking other modules? Well, actually, if you focus a bit here, not just a is even. Actually, if we discuss the cases like if k equals 1, 2, and 3, like then and greater than 3, then you will simply get that because this has 3 2's, because it's 2 cubed. This one has already like 2 here, and this one will have more than 2 squared. Then this one actually will be divisible by 8. So that's also a really useful thing. However, like we need to discuss the cases when k equals 1, k equals 2, and k equals 3 already work. So maybe this is useful. However, the most actually useful thing is not 2, not 8, but 13. Let's actually take modulo 13 and see. Like the really cool thing about it is that we already got rid of this thing. Because take a look here, like a, I don't care about a, because 13a is just 0, like congruent to 0 modulo 3. So if we took modulo 3 for the equation, this is basically 0. That means the right-hand side is just 8. So the right-hand side is congruent to 8 modulo 3. The left-hand side, however, is like 2 times this thing. So now actually we have an equation, using modulo, of course. So what is our equation? It's simply 2 times 10 to k minus 1 is congruent to 8 modulo 13. And because 2 is basically co-prime with 13, we can divide both sides over 2. So let's say actually we'll get rid of this 2, which is really cool. Like these are just some really simple properties about modulo. So this is just 4. Alright, so now how can we like deal with this thing here? 10 to the k minus 1 is congruent to 4 modulo 13. So actually, like if we, like instead of 4 have 1, then basically this is really great. Why is that? Because we have the order, that means that the order of 10 with modulo 13 divides k minus 1. So actually this is really famous results in number theory. Like if we have some number a to n is congruent to 1 modulo some number, like let's say for example here we're dealing actually with the simplest case like prime, then that means that basically the order, there is some number called the order of a, that of course with respect to p, that must divide n. And what is basically the definition of order? Actually, it is the smallest such number n that satisfies this. So for example, we try a to the 1, a to this, or like a squared, a cubed, and so on. Like what is the first number that satisfies this? This is the order. And that means that this order must divide any such n that satisfies this thing. So basically, if this was 1 here, then we will try like ourselves like to calculate what is the order of 10 and modulo 13. Like we'll try 1, we'll try 2, we'll try 3. And like when we find the order, that means that the order must divide k minus 1. And that of course like gives us some really useful hint about the smallest natural number, because remember we just need to find the smallest natural number. That means we just need to have an inequality that bounds it. All right. So if like that's only if we have 1 here. However, here we have 4. So like, can we do like actually anything here? Shall we give up, or like we still have hope? All right. So actually, we can try to handle that. But how exactly? Like we want here to have 1, right? How can we make it like try to handle this thing? this thing here. So basically, like we can try to manipulate these things. Well, like we know what is 10 modulo 13. Like we can write it as 10 or we can write it as minus 3. What about 4? 4 is actually minus 9 as well. So like the aim here is to try to make these the same number. Like this thing here, the same as this number here. Like somehow. Then like we can divide actually. So how exactly? Well, like this is really simple. Well, what is 10? Like we can subtract 13. We know that 10 is congruent to 10 minus 13, which is just minus 3 modulo 13. What about 4? We can do the same, like just subtract 13 and we'll just like get basically minus 9 modulo 13. So now clearly this is much more suitable than 10 and 4 because take a look here, minus 3 and minus 9. Now we can like try to divide here. So actually it makes sense to replace them by that. So like let's memorize that. 10 is minus 3, 4 is minus 9. Let's just like write that in a new equation. So now we know that. Of course, like minus 3 is just like minus 1 to k minus 1 times 3 to k minus 1 is congruent to negative 9. Basically, negative 9 is just 3 squared minus 3 squared modulo 13. Now that's really useful because now we can divide by 3 squared because it's coprime with 13. So now if we divide by 3 squared, this will be 3 to k minus 3. So that's perfect now. And of course, like we can handle easily with this negative 1. Let's move it to the right hand side, like by simply like just taking this one here. Well, like we'll just get the following: 3 to k minus 3 is congruent to minus 1 to the k. Like let me just check it. So this one is for sure true, 3 to the k minus 3, and this one is minus 1 to the k because we just like divide this, or like simply just multiply both sides by minus 1 to the k minus 1. This becomes 1 and this becomes minus 1 to the k minus 1 times minus 1, which is just minus 1 to the k. Alright, so now we have this really simple equation. Alright, 3 some power is congruent to negative 1 to the k. Well, like if it was 1, as we like agreed earlier, we'll be really happy. However, it's not 1, it's negative 1. So it's either negative 1 or 1 depending on the on the k. Like is it even or odd? Actually, we don't need like to discuss the two cases because guess what? Like we can square both sides, right? Like remember, like if we have like an equation, in any equation we can square the two sides, right? And here the same, like for modulo equations as well. If we know that a is congruent to b modulo some number, then a squared is congruent to b squared modulo the same number. So basically, now simply we can use this trick of squaring to get rid of this case, of this k. So now we know for sure that 3 to 3 times k minus 3, oh sorry, this is 2. This is congruent to 1 modulo 13. Alright, that's perfect. Now that's perfect for sure. Now we simply can use the order idea here because guess what? A to some number n is congruent to 1 modulo some number 13. So that means that the order of 3, now what we know for sure is that, like now let's erase this thing here. Now what we know is that order of 3 with respect to 13 must divide 2 times k minus 3. So what we really need to do now is just to find what is like to calculate the order of 3 with respect to 13. So how can we calculate it? Well, let's like do the simplest thing. Let's just try. Like, is it 1? Clearly no, because 3 to the 1 is not congruent to 1 modulo 13. Is it 2? 3 squared is 9. 9 is not congruent to 1 modulo 13. Is it 3? Well, guess what? 3 cubed is 27. 27 is 26 plus 1. It is indeed congruent to 1, modulo 13. So guess what? The order of 3 with respect to modulo 13, it's just 3. So that simply means, instead of this thing, we just know that 3 must divide 2 times k minus 3. And guess what? We don't care about 2 because like 3 does not divide 2. So that means that 3 must divide k minus 3. Alright, and in fact, if 3 divides k minus 3, we know that 3 divides 3, then that means immediately that 3 divides k. And that's really awesome, because now we know what are the possible values of k. 3, clearly like 3, 6, 9, and so on. So that simply means that we know k is just 3, 6, 9, and so on. Like it's any like a multiple of 3. But clearly we want to minimize k, find the smallest natural number. Remember that k is just the length of number n. So we just like need to try to find, like can we find using like just 3, k equals 3? Well, we'll try that. If we can't, we'll move to 6 and so on. So basically, let's try taking k equals 3. All right. So we'll just discuss the first case, that is k equals 3 first of all. K equals 3. Clearly here, we can substitute in this equation to get the value of a. So 3 minus 1 is 2. This is 200 minus 8. This is 192 equals 13 times a. So that basically means that a is just 192 divided by 13. However, actually, if you like check like this, actually 13 does not divide 192. So actually, this case, like we can refuse this case because of the divisibility condition here. Like this is not divisible by 13, so clearly a like cannot be an integer here. All right, so like k equals 3 is refused. All right, so now we need to discuss the other case, like the second case, that is k equals 6. So if k equals 6, we can do the same here, like that will be 2 times basically 100 to 5 minus 8 divided by 13, that will be a. And like I'm not really going to calculate that, however, like you can do it yourself and you will get actually an answer for that. That is a equal, okay, let me check. So a is basically all right, so 15, 3, 8, and 4. All right, so like if you just calculate this thing, you will get this number, and that is a. All right, so like now actually we know what is the smallest natural number n, because guess what? What is n? Well, if a is this thing, remember what was n? N is simply the same number, just with 6 at the last digit. So that's actually our smallest natural number n. That satisfies our problem. Clearly, like from this, like here, we've bounded like clearly we cannot have a smaller value, because like the only valid cases for k are 3, 6, 9, and clearly 3 does not work. So that's if 6 works, then it's the smallest one. Clearly 6 works here, so we're done basically. So as a summary, what we've done here was really simple actually. So first of all, we started with the problem. We of course analyzed the problem using digits, like we just use the decimal representation of a number by just assuming that n is just a6, and then like this process will be just 6a, and we assume that k is the number of digits of n, and then we entered everything into just equations, and we simply got this great like really great equation. This one was what we need to focus on. And how to solve such a thing here, we just like very important and common trick is just to use modulo some number. Which number should we pick? We'll just try to pick the coefficients here. Maybe 2, maybe 8, maybe 13. So 13 really like is the most helpful one here. So we took modulo 13. This one is the right hand side is just 8. We simply have this simple equation. 2 to the k minus 1 is congruent to 4 modulo 13. Well, we said that like we can solve it actually like as it is. However, like bringing order is really easier here. So like our idea was really simple. 10 is just minus 3, and 4 was just minus 9, which is minus 3 squared. So we easily just like turn this one into this one, and now we can apply the order easily. Of course, after we've done a very easy trick, that is minus 1 to the k. We just squared both sides. Now we have 1 here. So now we used like the results, the important result of order. That means that the order of 3 must divide the power here, the exponent 2 times k minus 3. What is the order of 3? It was really easy. It was just 3. That means that 3 divides k, and hence we have these cases. Clearly, if k equals 3 it does not work, because as we agreed, it cannot be divisible by 13. So we just tried the second case, and indeed it works. And we have our number, this number, n, which is the smallest such natural number, n, that satisfies our problem. Alright, so that was problem 1, not that difficult really. So like we will check like about problem 4 in the next video. Will it be as easy as this problem, or will it be more difficult? Alright, so if you guys enjoyed this video, please like, share and subscribe to the channel, and see you guys in the next video.